Welcome back to Math with Ms. Reimer. Today we are looking at sections 6B and 6C, which are quotient rules of exponents and simplifying large powers. Our quotient of powers property is the first one we're going to look at, and that's when we have two exponents or two bases rather, that are the same with different exponents. We can subtract their exponents, and that will give us our answer. For instance, if I have c to the fifth over c to the second, I can do c to the 5 minus 2, which simplifies to c to the third. Just like the multiplication rule, it only works when you have the same bases. Power of a quotient rule is if you have an exponent outside of a quotient or a fraction, you are allowed to take that exponent into the top and into the bottom of that fraction to get a to the m over b to the m in this case. For instance, if I have d to the third and f to the third, I can take that 3 to the top and to the bottom, and we get d to the third over f to the third. This combines with our multiplication rules, and this acronym MADS can help you there. When you're multiplying bases, you add the exponents. When you're dividing bases, you subtract the exponents. We learned the addition in section 6A, and today we're looking at the subtraction in our quotient of powers rule. Simplifying large powers, we will also get to at the end of this section, and the 3 steps are to bring the exponents from the outside of the parentheses, multiply the fractions together to form one large power, we'll squish them together, and then we'll simplify. When you're simplifying, there's no particular order you have to do this, but by the time you're done, you want to make sure you've evaluated all exponents, that all your coefficients are together and simplified, all your variables are together, and that there are no negative exponents left. We'll address negative exponents in section 6D. So let's run some examples here. In number 1, if I have 4 to the fifth over 4 to the third, the reason that the quotient of power property works is because this is the same as saying I've got 4 times 4 times 4, 5 fours, over 3 fours. Okay, now we know from our fraction simplifying properties that I can cancel out anything that's on both the top and the bottom. So all 3 of these sets will cancel out. When we do that, we're left with 4 times 4, or 4 squared. That's the same as if we had just done 5 minus 3 to get the 2 in our exponent. So that is why quotient of power property actually works. In number 2, we have 7 to the 13th over 7 to the 8th, so that will equal 7 to the 13 minus 8, or 7 to the 5th. In number 3, we end up with 2 to the 3rd times 2 to the 9th over 2 to the 4th. First, we want to simplify up and down on our fraction first, so we will combine the top 2 first. When we're multiplying, we add our exponents, so we'll get 2 to the 12th over 2 to the 4th. And once I have both of those, I can do 12 minus 4 to get 2 to the 8th. In number 4, I can take this y to the 18th and put it over 1, and then multiply these together. When I would do that, I would get y to the 18th over y to the 7th, and now I can subtract. 18 minus 7 will leave me with y to the 11th. In number 5, we get into power of quotient property. So we need to take that 5 from the outside of our parentheses in, similar to our power of powers property, but it also goes to the bottom of our fraction as well. So the 2 times 5 gives me m to the 10th, and the 5 with the n on the bottom gives me n to the 5th. When there's no exponent here, we know that there's an invisible exponent of 1, so 5 times 1 gives me 5. I can't simplify any farther from here because you are already at the m and the n cannot be simplified together. In number 6, we have our 3 to the 3rd over p, and so that 3 needs to come into both pieces, and we end up with 3 to the 3rd over p. If we're evaluating this all the way down, 3 to the 3rd will give me 27 over p. Now in 7 through 11, these are our large powers that we're simplifying. So we're going to follow our steps up here to simplify these large powers. So first in number 7, we are going to take our exponent from the outside of the parentheses in. When it comes in, it has to come into every single piece inside that power. So the 6 and the m to the 7th will give me m to the 42nd. On the bottom, we'll get a 2 to the 6th power and n to the 60th when we multiply. In our large powers, we're going to evaluate these all the way out, so I'm going to go ahead and figure out that 2 to the 6th is 64. And then my m and my n are already as simplified as they can get because there's nothing else to combine them with. And you can't combine them together because they don't have the same base. In number 8, we're going to take that 3 outside in first. Think of it just like distributive property. You've got to get rid of those parentheses first, and so that's the same thing we're doing here. That'll leave me with 4 to the 3rd, a to the 6th, 5 to the 3rd, b to the 9th. I took that 3 and I multiplied it by any existing exponent, and then I also put it towards my coefficients. Now I'm going to simplify. I need to evaluate those exponents. 4 to the 3rd is 64. A to the 6th is already simplified enough, and 5 to the 3rd is 125 over b to the 9th. If 64 over 125 simplified at all, I would have to simplify that farther. In this case, that's in simplest form already, but if you can simplify, you're going to need to. In number 9, we have to start by taking that 3 from the outside in, so we will take that to the x, to the 3, the y, and the 10. This second fraction is just along for the ride right now because it doesn't have anything to be distributed. So we'll end up with 3 to the 3rd, x to the 15th, over 10 to the 3rd, y to the 6th. I took that 3 and multiplied it by any existing exponent and also took it to my coefficients. I still have a times 5 to the x to the 4th left. You'll notice that step 2 in our process is to multiply the fractions together to form one large power. So I'm going to go ahead and smush them together. I can multiply everything together and just make this into one big fraction. When I do, I can start simplifying. The first thing I'm going to do is evaluate any of my exponents. So I know that 3 to the 3rd is 27. I know there's still a 5 up here. 10 to the 3rd is 1,000. And there's still a y, and the x has joined us on the bottom as well. Next, I'm going to go ahead and get that 27 and that 5 together because I know that they both are my numbers. I will multiply them to get 135, x to the 15th, over 1,000, y to the 6th, x to the 4th. Because I've been working with my coefficients, I'm going to go ahead and keep focusing on them. So my 135 and my 1,000 can simplify. Think of it just like simplifying a fraction, and you'll end up with 27 over 200. So when I rewrite this, I'll get 27, x to the 15th, over 200, y to the 6th, x to the 4th. So now I've taken care of my numbers in the front. They're in simplest form, but I still have to work on my variables. I see that I have an x on the top and on the bottom, so I can use my quotient property to simplify that. When I subtract those two, I'll end up with 27, x to the 11th from the 15 minus 4, over 200, y to the 6th. And those are the two pieces that I am looking for, and that's my final answer. 27 over 200 is in simplest form. The x's are together and the y's are together. In example 10, the first thing I need to do is bring that exponent from the outside in. So that 5 is going to come into the x, the 2, and the y on the bottom. When I go to rewrite this, 1 over 4x to the 5th is still there, with 2 to the 5th, x to the 10th, over y to the 15th. Now I can go ahead and smush my two fractions together into one big fraction because I can multiply across the top and the bottom in order to get that. Next, I'm going to go ahead and start evaluating my exponents. So 2 to the 5th will give me 32, and then times 1 is just still 32. X to the 10th is up top, and I've got the 4, x to the 5th, y to the 15th. While I'm at it working with my numbers, I'm going to go ahead and simplify the 32 and the 4. If I divide those out, I will end up with 8 on the top and 1 on the bottom. So I get 8x to the 10th over x to the 5th, y to the 15th. You can put the 1 on the bottom, but it's not going to matter if it's not there. Next, you need to simplify your x terms. And so we get x to the 10th and x to the 5th. When I subtract those, I will end up with 8x to the 5th over y to the 15th. More than one way to simplify these fractions down. You might do your steps in a slight different order, but you should still end up at the same final power when you're done. I need to bring this 2 into every piece in that second power. So I'm going to bring over my 3y to the 3rd over 5, and then have 10 to the 2nd, x to the 14th, 9 to the 2nd, and then y to the 16th. Because I multiply this 2 with the 7 and 8 that are already there and tack it on the 9 and the 10. Next, I'm going to go ahead and push my fractions together. So when I multiply them all together, it's like putting them all in one big fraction together. And then I'm going to start evaluating my exponents. On the top, I see I have a 10 squared, so that will give me a 100. So I'll have a 100 in here, x to the 14th. On the bottom, I have a 9 squared, which is 81, and then still my y to the 16th. On the top and the bottom, I can combine the 3 and the 100 and the 5 and the 81. So 3 times 100 will give me 300, still y to the 3rd, x to the 14th. And then on the bottom, 5 times 81 gives me 405. And then the y to the 16th is still hanging out on the bottom. Since I'm working on my numbers, I'm going to go ahead and simplify my 300 and my 405. And when I do that, I will be left with 20 over 27. So I will have 20 over 27, y to the 3rd, x to the 14th, y to the 16th. And as I am continuing to simplify, I notice that I still have 2 y terms, so I can subtract those two. Because the 16 is bigger, my y is going to end up on the bottom of this fraction. So I'll have x to the 14th on the top, and then 27 y to the 3rd, or rather to the 13th, there we go, on the bottom. Because I did 16 minus 3, the 13 will stay on the bottom of the fraction. That's all from me and Stanley.